So hello and welcome. In this video, we'll try to measure self and mutual inductance for brushless DC motor, and also we will measure the phase and line resistance for the motor. So let's start by measuring the self and mutual inductances. We can directly measure them by going here to design setting and check here the box for matrix computation, make it enabled, and click OK. Now we can go to results and create transient report. Select here rectangular plot to plot the winding inductances. Here you can find the self inductance for phase A, and for phase B and for phase C, and the mutual inductances between phases. For example, here between phase B and phase E, and so on. So select them all like this and make or create new report, and rename this report as inductance calculation. Actually, the upper waveforms here are for the self inductances, while the lower curves here are for the mutual inductance between phases. And regardless of the sign, the negative sign here, we can take the mean value for self and mutual inductances as shown like this by creating transient report and select data table, and also select here all of these inductances and take the mean value and click OK here, and the new report like this. You can also go to here, go to transpose and click OK. And also you can show all values in millihenry by selecting all values here, and go to edit properties and make the unit here millihenry for all inductances. So we can notice here a quite high value for the self inductance and low value for the mutual inductance between phases. And this is the variation for self and mutual inductances. So now we already calculated the inductances for the brushless DC motor. Let's calculate the phase and line resistances for the motor. Actually, we can't directly calculate the phase resistance from reports here in Maxwell, but we can use all design parameters such as stack length, number of turns, number of coils per phase to calculate the phase resistance externally. So here I made an HTML tool. This is the HTML tool to calculate the phase resistance for the motor by knowing its design parameters such as the stack length. The stack length for this motor is about 8 mm. The tooth width is about 3 mm. Slot depths here about 11 mm. And the end winding extension about 1 mm. And number of stator slots is about 24 slots. Number of phases is 3, and the coils per phase is 8. And number of turns is 120, and the temperature at measurement time is about 20. We can here define the conductor specification by using the standard, or by the wire diameter, or by cross-sectional area of the conductor, or by the American wire gauge for the conductor. So what I know here for this motor is that its wire diameter is equal to 0.29, and it has one parallel strand. So the measured line to line resistance, this is what we already measured by experimental, setup. This is a simple experimental setup here. We used a multimeter to measure the line resistance between phases for the motor. For example, this is phase A and phase B, and the line resistance here is about 15.9 ohm. And also we can measure the same resistance between phase A and C and phase B and C and so on. So now let's calculate by using this HTM tool the phase resistance. Here I will input the line to line resistance as 15.9 and just click here, calculate the winding resistance. So we almost get the same value for the line to line resistance here, about 15.8 ohm, and the phase resistance is about 7.9 ohm, and this is the mean turn length about 31.6 millimeter, and this is the total wire length about 30.3 meter, and this is the conductor area here and the resistivity of the copper. And this is a simple comparison between the calculated and measured values for the line resistance, line to line resistance about 15.9 ohm, and this is a summary of all results. And we can see here also all equations used in this HTML file for reference. So this is the an external way to calculate the phase resistance for the designed brushless DC motor. I used Perplexity AI tool to make this tool for measuring the winding resistance of the motor and estimating it. So this is here the brushless motor, and we actually don't define here directly the phase resistance in case of current excitation. We may need this value after that in case of voltage or external winding excitation. I hope that you enjoyed this video, and see you in next videos.